Hi, today we'll be working on some code in C. It'll be just, so we'll be going over logical operators in C. So I don't believe we've done this code already, so hopefully it'll be of help to you guys. So it's just part of the C series. So we'll just start with the main, yeah, let's just include we'll include the header file, so we'll include stdio.h. And then we'll have a void main. Hopefully you guys can hear, I just have like a binaural in the background. It's like a binaural beat. I don't know if you guys heard of that. It helps you remember stuff. Or it just helps you helps your mind grow better or something. I don't know. I just listen to it sometimes. So we have, hopefully it's not too loud. I have a noise canceling mic, so it shouldn't be too loud. So we have int I points to 5. Int b points to 20. Int c. Then we'll have, so this is the logical operators example. So we'll say if a and b, we'll say printf line 1. We'll have a string here, line 1. Condition is true. New line. Whoops. So we'll have a new line, and then we'll have that's it actually. So we'll just have if a and b, we'll print out this string, and we'll have a semicolon. Then here we'll say, so we'll close that square bracket, and here we'll say if a or b. Then we'll say print out line 2. Line 2 condition is true. New line. And then we'll say so here we're gonna change a and b here again, so we'll reset it to a points to 0, b points to 10. And we'll say if a and b again. We'll say printf line 3. Condition is true, new line. What's happening there? Why is that like that and the rest are not? So we have, okay, so maybe it's not going to hit then. So we'll just leave it like that for now. Maybe it's just saying it's an unreachable code. Sometimes they have that alert or something, the warnings. So here we'll have, so if a and b, print f, and then the string. Here we'll have an else. We'll just say print printf line 3 condition is not true. I was just looking how many more Java videos I have to upload. It's literally like 30 videos. More than that, 50 videos. Of just all data structure stuff. I have it sitting on my hard drive here. I'm gonna try to upload one every few days. I have so many videos and they're all mixed up, so I'm just trying to organize them. So if you guys are waiting for that, I promise they're coming out real soon. So we have line 3, condition is not true, new line. Then we have so it's gonna, if this line above is not true, if A and B is not true, then this else will get hit. This printf will print out condition is not true instead of it is true. So it looks like it is printing that right now. That's why this code, excuse me, it's all grayed out. I'm notorious for yawning in my videos. Apologize for that. So then we have we have the else, printf the condition is not true. Then we have if not A and B. So here we'll have if not. So if not, then in another parentheses A and B. We'll have printf line 4. Condition is true. And that's all. That should be all. So I'll just double check that. So we have, that's why I don't like spacing them out, because then everything gets, you can't see it on your screen. Okay, so we have oops, sorry, drop the mic. So we have if int A points to B. So int A points to 5, int B points to 20, int C, if A and B, print out line 1 condition is true. If A or B, print out printf line 2 condition is true. Then we change the variables, A points to 0, B points to 10. Then we have if A and B, printf line 3 condition is true. Else printf line 3 condition is not true. Then we have if not A and B, printf line 4 condition is true. So we'll just set a breakpoint here, save it, and then we'll just click the debug icon on the top right. Okay, so we'll just step in here. A points to 5, B points to 20. If A and B. So I believe in this case, it's basically saying if the number is not, as long as they're not equal to 0, it's true, I believe. We can double check that in a sec. Actually, why don't we just check that now? So we'll just have 1 equal to 0. Or if it has a value, could be 0 as well, so we'll just check here. Yeah, so if it's equal to 0, how can I explain this? So for a logical AND, am I gonna need to draw a whole bunch of stuff here to explain this. I might have to. Well, I might need to have to draw the truth table out for you guys off the top of my head, so let's just try to do that. So we'll just say truth table, okay, so I believe I have, so what's gonna happen is there's A and B, so there's two columns, A and B. I'm just gonna pull it up just to make sure I have the right diagram for you guys. I have a picture here somewhere. Okay, here we go. So I'm missing a third column. Okay, so there's three columns here. So we're gonna have A. We're gonna have a B, and we're gonna have A and B column. That's not or. So maybe I should do something else here, like that or something. No. Let's just do it with slashes, because those are like comments anyways. Okay, so we have A column, B column, and A and B column. So in C, just a reminder, false is equal to 0, true is equal to 1. I believe it can be any other value other than 0, but usually it should be 1. So then we have, so this false equals to 0 and true equals to 1, right? So I'm not gonna, I mean I could put false, true, false, but 0, 1, 0 works the same. So if, maybe I could try to, well, I guess writing it out every time would be dumb, but if we have A is equal to 0 and B is equal to 0, oops, I should do this like that. Okay, so if we have A is false and B is false, then A and B is false. Should be false. So then now if we have A is equal to 1, if we have A equal, so A is equal to true, B is equal to false, so A is equal to true or 1, B is equal to false or 0, then A and B is equal to false, because in order for A and B to be true, they both have to be true, right? Just one of them can't be true. So hopefully you guys understand, and maybe I'll just put something else down here just to space that out like that. Okay, so, okay, there we go. So if we have, there should be one more. So if A is false, false or 0. If B is true or 1, 1 or true. So 0, 0, 0, 1, 0, 0, 0, 1. So if A is false and B is true, then A and B is still false. And lastly, if A is true and B is true, if A is 1 and B is 1, then both are true. So the only way it's if the only way they're both so the only way A and B, or basically you can say this I guess in two ways. The only way if A and B is equal to 1 or true is if both are 1 or another or anything other than 0, right? Or we could say if A and B is equal, the only way A and B is equal to true is if A is 1 or true, or B is 1 or true, or another value other than 0. So A is a value other than 0, and B is a value other than 0. So that's what I believe is happening here. That's why this line didn't get executed when we changed it to 0, because it was a value other than 0, indicating that the logical condition was not met and that it was false. So hopefully that helps. We're going to need one for OR as well, probably. It's not a big deal, we could just copy these, change it, and change the values. So we have, so now let's just restart that. Okay, I guess we're going to need another one here as well. A and B, not A and B. So there's different, these are logical gates or Boolean, they're logical operators, but there's also Boolean gates involved with these, because if it's like and, that's a special kind of gate, truth table itself. So there's and and or. It's spelled like n and then and together, so NAND. A NAND gate and a NOR gate, so it's like an or a NOR gate. We don't have a NOR gate here, we just have a NAND gate. That's a NAND gate, or like a NAND truth table. So we're gonna need, I guess, at least 2 more truth tables. Whoops, sorry. Hit the mic with my pillow. Okay, so we have we're gonna need the OR truth table, at least in this case, so we'll have this copied out one more time. Actually 2 more times, but we'll just start with 1. And we'll have OR here. So we really just need to change those ones. So if we have false is equal to 0, true is 1, or any other value other than 0, I guess. Then we have A, we have the column A, column B, and then the column A or B. So same values. So for the first one, if A is false or 0 and B is false or 0, then A or B is false or 0, right? Because in order for one to be true, at least one of them has to be true or any other value other than 0. Any value other than 0 in this case, because if we have a voltage on a circuit, then we have so if we have like a signal, a digital signal or a circuit, and we're applying electricity to a circuit, it's either going to be 0 volts or it's going to be 5 volts. So 5 volts is indicated as 1 or true, and 0 volts is indicated as 0 volts or false. I'm not an electrical engineer, I'm just a software engineer or like computer science. So we don't do too many circuit boards. We get 1 class on it, and that's it. So it's like pretty much that's all they really told us as far as electricity, how it works. So that's all I really know about that. But otherwise here, so we have 0 for, so we have if A is equal to 0 and B is equal to 0 or false, then A or B will be 0 or false. If we have 1, so if we have A is equal to 1 or true, B is equal to 0 or false, then A or B will be 1 or true, because we have at least 1 to satisfy the logical or the OR gate. So here we have the same thing, basically just opposite. So if we have A is equal to false or 0, and B is equal to 1 or true, then A or B is equal to 1 or true, because we have at least 1. So for the last one, if we have I might as well just do all the gates with you guys, or at least all the truth tables, so you guys would know for reference. Maybe I can. It's not a big deal. It's only 5 of them. So we have. So if we have A is true, or so if A is 1 or true and B is 1 or true, then A or B will be true, of course, because we have at least 1, and we have both in this case. So that's the logical AND truth table. This is a logical OR truth table. We'll do the logical. We'll just do the logical NOT, I guess. So A, B. I'm missing something here. Whoops. Okay, so this is also input, so this is input A, input B, and output A or B. So you could put like you could think of there's an input here as far as a logical gate. So A and B are input and A or B is output. Here, same thing, it's all the same like that. Sorry, this one I guess, since that's a duplicate. Input A, input B, and then output A or B. So if we have this one only has 2, logical NOT only has 2 values. That's false. This isn't. There's no third column here. So for a logical NOT, we'll just say it's a NOT. So if we have A is false, so if we have A is false or 0, then we'll have, so that's the input A. So the input A, there's no input B here, is there? Nope, we just have A and then out. So if we have, for the input A, if we have 0 for a logical NOT, so 0 false and the output will be true because it switches it. So if we have the logical NOT for 1 or true, then it's going to be a false or 0. That's logical NOT. That's it. It's pretty much the easiest one to remember, obviously. They're all, like, I guess obviously it's not that hard to remember them, but it might be if you don't know them, I guess. Like, you have to remember AND is both of them and OR is just one to be true. To be true for OR, sorry, to be true for AND, both have to be true. To be true for OR, only one has to be true. So that's all you really have to remember. So there's 2 more. There's a NOR and a NAND. So which one do we have here? We have a NAND because it's not AND. So we have. So I'll just take this AND here. Okay, so as far as gates go, logical gates go, by the way, you can associate or with a plus, so like a plus b, if you're doing the functions with it. I won't be able to explain those in this video, at least. The gates. There is a good video out there by the Chem Tutor if you guys are looking for it. The organic Chem Tutor if you guys need that. I don't think I'll be able to do those with you because I'll have to draw a whole bunch of stuff. But just if you're associating this with any function at all, you're going to need a plus. For and, it's going to be a multiplication. So a dot b or a times b. I'll just do a dot to signify multiplying. For a not, there's nothing. For a NAND, so the NAND gate uses a special symbol that can be like a underline. So it can be an underscore or like a apostrophe to signify what do they call it? I forgot the word, to be honest, but it just tells you that it's going to be a not. It's another way to write not. So we take this and truth table here. And what we're gonna do is just copy it, and then we're gonna put it down here. So we'll just say, maybe we could just say that this is and this is or, sorry, this is not. This is or, this is and. So here we have an and, so it's going to be, so false is equal to 0, true is equal to 1, A and B it's really written like not A and B, but it's written in another way, but that's okay, we'll just do it this way, it doesn't really matter, so it's like not A and B. It can also be written like this, A times B with an apostrophe like that, or an underscore, something like, or like a line above the B or something like that. So here it's, so what's going to happen is we're going to negate everything that we're going to negate everything in an AND gate. Sorry, we're gonna negate everything in an AND truth table. So if we have, this is our AND truth table, right? Above here, we're just gonna negate everything. So we're gonna flip everything. 1 becomes 0, 0 becomes 1, 0 becomes 1, 0 becomes 1. I'll explain why. So if we have, it's just, it takes the logical not of an AND gate. Really, that's all that's happening. So if we have, remember, for an AND gate, both have to be true for it to be true. That means everything else would be true in the other case. So only one has to be true here, only one has to be true here, false is going to be true, and if they're both true then it's false because it's a logical not of an AND. That's all it is. So hopefully guys you get that, and then we'll just do the last one just in case you guys need it. So you just take, we have a NOR gate, it's false, then we have, so here we have A plus B with the colon, or the apostrophe. Colon or apostrophe, what symbol, whatever symbol that is, I forgot. So we have, here we have, so it's a not. It's basically like a not, like this, like a not or, so a NOR, that's what it is. and everything gets flipped here again. Whoops. So false becomes true, true becomes false, true becomes false, true becomes false. So 0 became 1, 1 became 0, 1 became 0, 1 became 0, because it just takes an OR. For an OR you just need 1 to be true, right? So if you only need 1 to be true, then all the truths will turn to false. And if your one that's false is false, then it's going to become true in a NOR truth table or a NOR gate. So there you go. You guys have that now for reference if you need it. So that way we can go through these again. So we'll just start with the debug icon again at the top. So I would suggest, I would say that if you are taking any kind of University C class, that you'll probably get tested on this. So it's good to know it. And of course we use these operators all the time, like logical operators in any language, all the time. You use these definitely, and or all the time. You're gonna need those, so you definitely need to know those for sure. Not really like this, because you kind of put two statements together. You don't really just check one variable like that. I mean, you might need to, but usually not. But that's alright, so we'll just continue with that. So we'll step in. So we have A points to 5, B points to 20, C, then we have if A and B, so they're both not 0, so it should be true. It's just going to execute. So in the output you should see that. Not on my screen because I'm C-line's glitched, so it won't write to the. It won't really show. It won't debug basically to the console here. It has to be external for some reason, so you guys can't see that. So if we have, here if we have int A or B, so it should be true again because at least one is not 0 in this case, so both are not 0, so it should be true. Step out. So now we're saying, see, that's why they changed it to 0 here, to show that this one wouldn't get hit this time. Because if we go down to our logical AND, we need both to be not 0 or true, or 1 to be true. And in this case it's going to be false because 1 is 0, that's why this line doesn't get hit. So A points to 0, B points to 10. If A and B, that's false this time, as we just said. That printf condition isn't true, so that line got printed to my output. So then now we're saying if not A and B. So it's a little tricky, so it's saying, okay, well, if we have to our NAND gate, let's go down to our NAND gate. So in our NAND gate we have one value is 0 and one value is a value other than 0. So basically a false and a true. We have a 0 and a 1, false and a true. So if we have a false and a true, here, it's going to be true because in a normal AND truth table or gate, you need both to be true. But in this case, so if we have both to be true, that would be true in an AND gate. But in this case, we only have one, which is false, so it switches it to the on state in this case. So the 0 could be an off state, 1 can be an on state as well, as far as electricity circuits go. So then if we have So booleans are used in electricity circuits. So if we have if A and B, which would be false in this case because 1 is 0, then we're saying take the NAND of that, or take the logical NOT of that, which would flip it from false to true. So it's going to be true this time. So hopefully you guys understand. It's a little confusing, but just check the diagram if you're confused, and then print it out. So there you guys go. That's logical. Which code was this? I think it was logical operators. Yeah, it was logical operators in C, truth tables, and a little bit of gates. Boolean Gates. So hopefully that helps you guys. If you guys want to see more programming videos or investing videos, you guys can subscribe to the channel for more tutorials, and I'll see you guys next time. Thanks for watching. Take care.